Hi everyone, we're going to express the function as the sum of a power series by first using partial fractions and then also find the interval of convergence. So let's start with the partial fraction decomposition. We're going to write this as equal to x plus 2 divided by 2x plus 1 times x minus 1. And then this is going to equal a divided by 2x plus 1 plus b divided by x minus 1. Clearing the fractions, we're going to get equals x plus 2 equals a times x minus 1 plus b times 2x plus 1. Now, let's let x equal 1. And that's going to clear my a out. So when I substitute in 1, I'm going to get 3 for this. And I substitute in 1 for this, I'm going to get 3 equals 3b. Therefore, b equals 1. Now let's let x equal negative 1/2. So that will clear the b. And this is going to give you 3/2 equals negative 3/2 a. So a is going to equal negative 1. So what we have is this equals, for this, I'm going to substitute in negative 1 divided by 2x plus 1 and then plus 1 divided by x minus 1. Now our goal is to write a function in the form of 1 divided by 1 minus r, a geometric series, where our r, our convergence, is going to be less, absolute value of r is less than 1. All right, so let's do that and write this using this equation, formulate it so we can write it like this. So for the first piece, we're going to write, I'm going to look at this piece. So this is going to equal negative 1. So we get 1 divided by, I'll move the 1 first. This can be written as 1 plus 2x. So I'm going to write this as 1 minus a negative 2x. So that gives me the plus 2x. All right, and then for the second piece, that's just going to be minus 1 times 1 divided by 1 minus x. And the reason being is I multiplied the numerator and the denominator by negative, and so I could write this in this form here. All right, now that I have that, I'm going to write it as a sum. So since I have that form, this is going to be your x here. This is going to be your x. So what we're going to get is, and I'm factoring out this negative 1, we're going to get negative 1, I'll just put negative, the sum of n equals 0 to infinity, and then your x was negative 2x, that's going to be to the nth power. And then the second piece we had was negative n equals 0 to infinity of x to the power of n. Now I can simplify this by factoring out x to the nth. So let's do that. We're going to get negative times the sum of n equals 0 to infinity. And this is going to be negative 2 to the nth plus 1. And then we're going to have x to the power of n. So I'm pulling this negative out for both pieces. So 2 negatives here will make a positive. All right, so this is the better way to write it. And now we're going to look back at these two to find the interval of convergence. So for the first piece, this is your r, and this x is your r. So for the first piece, we have absolute value of negative 2x is less than 1. We can change that to positive because absolute value. So the absolute value of x is less than, if you divide both sides by 2, it's going to be 1/2. So your interval of convergence for this is going to be x belongs to negative 1/2 to 1/2, which equals your interval of convergence. For the second piece, this is just going to be absolute value of x is less than 1. So x is the interval of convergence is from negative 1 to 1. That equals your interval. We have to take both pieces together, and so we have to take the smaller one. So your interval of convergence is this one, because this one will not work with that one, but this one will work with this one. So our interval of convergence, you can also write it like this, because that's the definition of this. But most of the time they just write it like this. Thank you. Have a nice day. Bye-bye.